Hare Krishna. This is my 13th video, and today again I am going to teach you the derivative of a parametric function. In the last session, we have studied about the derivative of a implicit function, and there I have told you that what do you mean by the implicit function. Now first, what do you mean by the parametric function? Because here in the derivative, many type of a differentiations are there. So I have to take one by one, isn't it? So what do you mean by the parametric function, and how will you find out the derivative of a parametric function? Now you know, suppose this is the any point in the plane. Can you locate the exact position of this point in the plane? You can locate, but suppose anybody says it is middle of the board, it is at the left hand side of the board. It is not the case. With the help of the coordinate geometry, with the help of a coordinate system, you can locate this. Whenever you have to locate this point in the plane, what you have to do? You have to establish the coordinate system by drawing the x-axis as well as the y-axis, and then you can locate this point, isn't it? Now you draw the perpendicular on x-axis, you draw the perpendicular on y-axis. This horizontal distance, it is nothing but x, vertical distance, it is y. Then you can say that is the px comma y. Therefore, the any point in the plane can be denoted by the order pair x comma y, where x is the horizontal distance and y is the vertical distance. And whenever the x and y coordinate of the any point, it is expressed in one variable, that is called as a parametric function. Now when you express x is equal to a cos theta and y is equal to a sin theta, means x it is denoted, म्हणजे या x ची आयडेंटिटी कशाने डिनोट करतो आपण थीटा, here also theta. Therefore these are the parameters. There are the parameters. What do you mean by the parameters? That with the help of that parameter you have to measure something, isn't it? This is also the parameter. Theta is the parameter by which you can say x it is in the form of a theta and y it is also in the form of a theta. When x and y coordinate of the any point, it is expressed in one variable, in one parameter, that is called as a parametric function, isn't it? Suppose I write x is equal to 80 square and y is equal to twice 80. Here t is the parameter, isn't it? Here t is the parameter, not that is what here a is the parameter. Suppose that is m square plus 1, and here suppose y is equal to 2m cube, right? Here m is the parameter. So there are the different parameter. When the x and y coordinate of the any point, it is expressed in one variable or in one parameter, that is called as a parametric function, isn't it? And how will you find out the derivative of such a parametric function, isn't it? Now see here. Again there is a one theorem of the parametric function, that is, suppose x is the any function, it is in the form of a theta, and suppose x is equal to g of t, and suppose y is equal to f of t. Means x is the function of a t, y is the function of a t, then differentiate with respect to t, dx by dt, it is equal to g dash t, and here dy by dt, it is equal to f dash t, and here that is dy by dx, but we want to find out the derivative with respect to x, therefore dy by dx, it is equal to f dash t and divided by g dash t. One theorem it is also there, that is this you can write as a dy by dt divided by dx divided by dt. Therefore here remember dy by dx, it is always equal to dy by dt, and here divided by dx divided by dt, right? So this is the theorem, isn't it? Now by this theorem you have to solve the problem. Now I will take one simple problem. Suppose let x is equal to a cos theta and y is equal to a sin theta. Now since x is the function of a theta, you have to differentiate with respect to theta. Y is also the function of a theta, you have to differentiate with respect to theta. Therefore dx divided by d theta, a remain as it is. The derivative of a cos theta, that is equal to minus sin theta. Similarly dy by d theta, again a remain as it is. The derivative of a sin theta, that is equal to cos theta, right? Therefore dy by dx, it is nothing but dy by d theta divided by dx divided by d theta, right? Again, what is dy by d theta? A cos theta. What is dx by d theta? Minus a sin theta. Again, A get cancelled. Here you have got cot theta. Isn't it? This is the first simple example. Suppose second one. Y is equal to 80 square and x is equal to twice 80. Isn't it? Again, y is the function of 80. X is the function of 80. You have to differentiate with respect to t. dy by dt. It is equal to a remain as it is. The derivative of a t square, that is equal to 2t. Again, dx divided by dt. Again twice a. The derivative of a t, that is equal to 1. What do you want here? We want dy by dx. Therefore, dy by dt. Here again dx divided by dt. Right? Dy by dt, that is twice at, and dx by dt, that is twice a. Get cancelled, and you have got the result, that is equal to 2. This is about the parametric function, isn't it? When the x and y variable of the any point, it is expressed in one parameter or one variable, then it is said to be as a parametric function. And what is the rule here? Dy by dx, it is equal to dy by dt divided by dx by dt. Since we have taken the function of a t, here also the function of a t, therefore your formula, that is dy by dx, it is in the form of a t. But when you take the function in the form of a theta, then your formula becomes dy by d theta divided by dx by dt, isn't it? So this is about the rule and this is about the parametric function. Now I will take some important examples here. So very carefully, each and every example, it is different from each other. So I will take the examples, simple examples. See, here I will take the first example. If, first example, if x is equal to a root of sec theta minus tan theta, again y is equal to a root of sec theta plus tan theta. Here we have to prove that dy by dx, it is equal to minus y by x. Right? Again very simple here. X is the function of a theta, y is the function of a theta. You have to differentiate with respect to theta. See here, x is equal to a root of sec theta minus tan theta. Right? X is the function of a theta, differentiate with respect to theta. When the constant it is multiplied to the function, constant remain as it is. Again you have to apply the chain rule. This is u. The derivative of a root u, that is 1 upon 2 root u, means 1 upon 2 root sec theta tan theta. Again d by d theta of a sec theta chi derivative sec theta tan theta, and again the derivative of a tan theta, that is equal to sec square theta. Now again if you observe this, you can take sec theta common, isn't it? This a remain as it is. A remain as it is. You can take sec theta common, right? Sec theta, and here you have got tan theta minus sec theta, right? Divided by again 2 root of sec theta minus tan theta. Now see, if you take minus n common, you have got sec theta minus tan theta, isn't it? That term, it is in the denominator, so that one root get cancelled, because the every number, suppose x you can write in the form of a root x into root x, right? Therefore here what you have to do, see here, you can take minus n common, means minus a sec theta, and here you have got sec theta minus tan theta, right? Divided by 2 root of sec theta minus tan theta. Again this function, that is sec theta minus tan theta, you can write in a 2 root, isn't it? So that root of sec theta minus tan theta, root of sec theta minus tan theta, 1 root of sec theta minus tan theta get cancelled, minus a by 2. This is sec theta. Now here you can write sec theta minus tan theta. Again root of sec theta minus tan theta, right? Divided by again root of sec theta minus tan theta. Again one root get cancelled, minus a by 2 sec theta, and again if you observe this, the sec theta minus tan theta, it is nothing but here, that is only sec theta minus tan, or you can consider that is a also here, a into sec theta minus root of sec theta minus tan theta, a into, see here, a into root of sec theta minus tan theta, it is nothing but x, right? Therefore, in place of this, that is dx divided by d theta, we can write as a into this minus 1 by 2 sec theta remain as it is, and a into root of sec theta minus tan theta you can write as x, and this is the right. Again you can consider y is equal to a root of sec theta plus tan theta, right? Again dy by d theta, a remain as it is, root u, apply chain rule, 2 root u means 2 root sec theta plus tan theta. Again, the derivative is sec theta, that is sec theta tan theta, and here again plus tan theta sec square theta, right? Now again you can take sec theta common. Here you have got tan theta plus sec theta divided by a root of sec theta plus tan theta. Again this term you can write in a 2 root. Therefore, automatically one root get cancelled, and what is remain here? That is a sec theta root of tan theta plus sec theta, isn't it? Now again see, this is 2 divided by 2, because one root get cancelled, isn't it? This you can write as a root of tan theta plus sec theta, root of tan theta plus sec theta, one root get cancelled, what is remain? A by 2 sec theta, again a by 2, 1 by 2 sec theta remain as it is, and again if you observe this, say y is equal to a into root of sec theta plus tan theta, again a into root of sec theta plus tan theta, it is nothing but what is y, and this is sec. Now from first and second, what do you want here? Dy by dx. Therefore, dy by d theta, you have to apply the rule, divided by dx divided by d theta. Again dy by d theta, what is dy by d theta? Here you have got dy by d theta, it is nothing but that is 1 by 2 sec theta into y, right? Again, what is dx by d theta? Minus 1 by 2 sec theta into x. Again 1 by 2 get cancelled, sec theta get cancelled. Here you have got the result, that is minus y by x, right? Such a type of a problems, these are very important in what is parametric function. So this is about the parametric function. This is the first important problem I have taken. Now see the second one here. Second one. Here again, if you observe this, x is equal to e raised to sine 3t, right? And y is equal to e raised to cos 3t, and you have to prove that dy by dx, it is equal to minus y log x and divided by x log. See this problem. Again I will rub this. Then you can proceed to the next problem. Isn't it? Now see, if you observe this, first you have to observe the problem. What you have to prove? That is dy by dx, it is equal to minus y log x divided by x log y. Means in your answer, there is an inclusion of a log, isn't it? Therefore, it is better to take log both sides. This is also you can do, but at last you have to take the log. Therefore, taking log both sides, if you take the log both sides, it is better to find out this answer, isn't it? Therefore, take log both sides. Log of x is equal to log of e to the power sine 3t, isn't it? Again log x, here sine 3t, and log e, it is nothing but what here? 1. And this is number 1. Now if you observe this, x is the function of a t, therefore differentiate with respect to t. Therefore you have to consider here, don't write directly the derivative, you have to write like this, d by dt of log x, and here d by dt of sine 3t, right? Again derivative with respect to t, and your function it is of a x. Therefore, how will you find out? The direct derivative of a log x, that is 1 by x. What you have to do? Take x from this, take t from this, and multiply with dx divided by dt. Since this is the function of a t, directly you can find out the derivative. The derivative of a sine 3t, that is equal to cos 3t, and the derivative of a 3t that is equal to 3. Again, dx divided by dt, it is nothing but 3x cos 3t. This is same. Right? Again, y is equal to e to the power cos 3t. See, taking log both side, log of y, it is equal to log of e to the power cos 3t. Again, log y, you can write as a, this cos 3t, you can multiply, and the value of a log e, that is always equal to 1. Again, differentiate with respect to t, d by dt. This is again the third one. Again, d by dt of a log y, and here again d by dt of a cos 3t. Again, the derivative with respect to t, and your function it is of a y. Therefore, as usual, what is the derivative of a log y? 1 by y. Take y from this, take t from this, and multiply with dy by t. And the derivative of a cos 3t, that is minus sin 3t, and the derivative of a 3t, that is equal to 0. Again, dy divided by dt. This y you can multiply it, minus 3y sin 3t. This is fourth. Again, from second and fourth, dy by dx, it is equal to dy by dt divided by dx divided by dt. Again, what is dy by dt? Dy by dt, it is minus 3y sin 3t, and divided here, this is 3x cos 3t. 3 get cancelled, but in your answer there is an inclusion of a log. Therefore, see here, you know that is the sin 3t, it is nothing but what your log x. Therefore, you can put log x, and you know again cos 3t, again that is equal to log y, and this is from what? First and now you have got your answer, that is minus y log x divided by x log y. Therefore, dy divided by dx, it is equal to minus y log x and divided by x log y. This is again the very important problem from the parametric function, isn't it? So this is the second one. You have to observe the problem. Since there is an inclusion of a log, it is better to take log both, isn't it? And here also you have to note one point. Log x is equal to sin 3t, means x is the function of a t. Therefore, differentiate with respect to t, means d by dt of a log x and d by dt of a sin 3t. Since the derivative with respect to t and your function it is of a x, therefore, first you have to differentiate with respect to x and multiply with what here? Dx divided by dt. Log x, the derivative of a log x, that is 1 by x, multiply with dx divided by dt. This point you have to remember, right? Again the third one, see, third important problem I am going to take. See, the third one, that is the derivative of a parametric function. The derivative, that is very fast, and to cover all the variety, it takes the long time. The classes generally completed in 8 days only, 8 days, 10 days, isn't it? Classes also, when you are giving the fees, then also they are going to complete in a 10 days. They are only completing, and you are giving the fees, you are taking the tuition, but through my video, you will get the deep knowledge, you will get the variety of a problem, so that you can yourself study the calculus, isn't it? So, let us take the fourth one, that is third one. Third also very important. X is equal to a cos cube t, and y is equal to a sin cube t, and you have to prove dy by dx, it is equal to minus y by x whole raised to power n, isn't it? Now, as usual, what you can do, a into cos cube t, you can differentiate with respect to t, isn't it? Directly you can differentiate with respect to t dx by dt, because this is your regular method. What is the derivative of a cos cube t? That is 3 cos square t. And what is the derivative of a cos t? That is equal to minus sin t, isn't it? Similarly, y is equal to a sine cube t, and here again dy divided by dt you have got as a 3 sine square t, and the derivative of sine t, that is equal to cos t. This is same. Again you know dy by dx, it is equal to what here? Dy by dt divided by dx divided by dt, right? Now 3 a sine square t into cos t, and here again from first and second, that is 3a cos square t and sine t, this is minus. Again 3a get cancelled, cos t get cancelled, sine t get cancelled. Here you have got sine t divided by cos t tan t, but write down sine t cos t remain as it is. But what is your answer? When you do regularly, you have got this answer. Now you have to manage the answer, isn't it? You have to manage the answer like this. This is number 3. From this, here you have to substitute the value of a sin t and cos t in the form of a x and y. So what is given here? X is equal to a cos cube t, means x divided by a is equal to cos cube t. Suppose you take the cube root, that is x by a whole to the power 1 by 3, it is equal to what here? Cos t. Similarly, y by a whole to the power 1 by 3, it is equal to sin t. Now can you substitute? You can substitute here, that is dy divided by dx, it is equal to minus, what is the value of a sin t? That is y by a whole to the power 1 by 3, and here again that is cos t x by a whole to the power 1 by 3. Now you know the denominator y to the power 1 by 3, here also y to the power 1 by 3, this get cancelled, minus sign remain as it is, y by x whole to the power 1 by 3. Right. Here also you have to manage the problem. Now this is one method. So see the second method here. By this method also you can do. Again x is equal to a cos cube t and y is equal to a. This you can write as a x by a, that is cos cube t. Suppose you take the cube root, means x by a whole to the power 1 by 3, it is equal to cos t. Right? This is again number 1. Second method. Second method. Right? Again y is equal to a sin cube t. Therefore y by a is equal to sin cube t. Therefore y by a whole to the power 1 by 3, it is equal to sin t. This is same. Now see what you have to do. Squaring and adding. Squaring and adding first and second. If you make the square of this, you have got x by a whole to the power 2 by 3, and here again y by a whole to the power 2 by 3, and here you have got, that is the cos square t plus sin square t, and the cos square t and sin square t, it is equal to, means by this method you can completely eliminate what here t, and your function, it is in the form of a x and y. Now it is easily you can find out the derivative. See, 1 upon a to the power 2 by 3, constant remain as it is. What is the derivative of x to the power 2 by 3? That is 2 by 3. X to the power 2 minus 3 means minus 1 by 3, isn't it? Again here 1 upon a to the power 2 by 3 remain as it is. The derivative of a y to the power 2 by 3, that is 2 by 3, y to the power minus 1 by 3 into dy by dx, it is equal to 0. Right? Now 1 upon a to the power 2 by 3, this is 2 by 3, y raised to minus 1 by 3 into dy by dx, it is equal to, transfer this term at this side, minus 2 by 3, 1 upon a to the power 2 by 3 and x to the power minus 1 by 3. Again 2 by 3 get cancelled, this get cancelled, dy by dx, it is equal to, this is minus sign remain as it is, x to the power 1 by 3 divided by y to the power minus 1 by 3. Right? Therefore the negative index you can convert into positive, minus sign remain as it is. So this take in the numerator, this take in the denominator, you have got y by x whole to the power. This is about the second, right? This also you can do, and this also you can do. Here you have to manage, because your answer, generally the boys directly write that is sin t divided by cos t, that is equal to tan. Then you can't proceed further. Right? पुढचे मार्ग तुम्हाला बंद होतील. Right? Therefore, this also method, the second method also very useful. Any method you can choose yourself, right? So this is about the third one. Now I will take the fourth one here. The fourth important. Fourth one. See. X is equal to 2 cos raised to power 4 t plus 3. Y is equal to 3 sin raised to power 4 t plus 3. And show that, prove that dy by dx, it is equal to minus root of 3y divided by 2x. Again see, directly also you can do, but I will give you the second method here. Say x is equal to 2 cos raised to power 4 t plus 3. Now this you can write as a x by 2 cos raised to power 4 t plus 3. Taking a square root, taking square root, both sides. Then you have got root of x by 2. It is equal to cos square t plus 3, and this is number, isn't it? Again y is equal to 3 sin raised to power 4 t plus 3. Again y by 3 is equal to sin raised to power 4 t plus 3. Again taking a square root, taking square root, both sides, root of y by 3, you have got as a sin square t plus 3. Right? This is second. Now you can add this, that is adding first and second. You have got that is root of x by 2 plus root of y by 3. It is equal to, suppose you add this, that is the cos square t plus 3 plus sin square t plus 3. It is equal to, isn't it? So now you can directly differentiate because the t get eliminated, isn't it? Now 1 upon root 2, this is constant, remain as it is. What is the derivative of a root x? That is 1 upon 2 root x. Again 1 upon root 3, constant, remain as it is. What is the derivative of a root y? 1 upon 2 root y into dy by dx, and the derivative of a 1, that is always equal to 0. Therefore here this you can write as a, this is 2, this is root 3, this is root y into dy by dx, and transfer this term to that side, minus 1 upon 2 root x, isn't it? Again 2 to get cancelled, dy divided by dx, it is equal to minus root 3 root y divided by root 2 root x. Now this you can take in a one root, that is root of 3y divided by, this is root, again you can take in a one root, that is you have got as a, the root of minus root of 3y divided by 2x. This is the result we have got. This is about the fourth one. Again very, very important, right? Now I will take the fifth one here. These are very, very important problem from my parametric function. You can't complete the derivative in only 8 days, isn't it? So what? This is the so vast variety of your problems are there. When you deal yourself, you can't solve that problem yourself. Right? Therefore, I am giving you the variety of a problem. Now the fifth one is here. x is equal to log of 1 plus t square. Here y is equal to t minus tan inverse of t, isn't it? And you have to prove that that is dy by dx. It is equal to root of e raised to x minus 1 divided by. Again see here, x is equal to log of 1 plus t square. X is the function of a t. Differentiate with respect to t. dx divided by dt. Again apply the chain rule. The derivative of a log u, that is 1 by u, means 1 upon t square, and the derivative of a t square, that is equal to 2t. This is number 1. Again y is equal to t minus tan inverse of t. Y is the function of a t, differentiate with respect to t. The derivative of a t 1 and the derivative of a tan inverse t 1 upon 1 plus t square. Cross multiplication 1 plus t square minus 1 divided by 1 plus t square. Get cancelled, t square divided by 1 plus t square. This is same, isn't it? Now, since we want dy by dx, therefore apply the theorem, that is dy by dt divided by dx divided by dt. What is dy by dt? That is t square divided by 1 plus t square and divided by c, that is 2t divided by 1 plus t square. 1 plus t square you can take in the numerator, divided by 2. Get cancelled. Again 1t get cancelled. Here you have got half. Now the answer you have not got. Again what you have to do? Manage the problem, isn't it? Now this is third here. You have got. Now see how will you manage the problem. Here what do you want? E raised to x. And the e raised to x you itself get from what here log, because the log can be converted into what here e. So see here again, since x is equal to log of 1 plus t square, therefore when you take log inverse, means you can't write like this. The log inverse, it is nothing but what here e raised to, right? E raised to something. When you take log inverse of x, means it is nothing but what here e raised to x is equal to 1 plus t square. Again you want t, therefore e raised to x minus 1, it is equal to t square. Therefore t is equal to root of e raised to x minus 1. Now put this value in third. Put e third in a third equation. Therefore here you have got dy by dx, it is equal to half remain as it is. In place of t you can substitute root of e raised to x minus 1. So this is about the fifth one, isn't it? Fifth problem. X is equal to log of 1 plus t square. Y is equal to t minus tan inverse of t. And you have to prove that is dy by dx, it is root of e raised to x minus 1 divided. Isn't it? You have to manage the answer here by substituting like this. That is the log e to the power x you itself get from the log, right? This is fifth one. Now I will take sixth one. See. Sixth one. No, I have taken 6. X is equal to sine inverse of e raised to t and y is equal to root of 1 minus e raised to t, and you have to prove that sine x plus dy by dx, it is equal to 0, right? No, see. Again x is the function of a t, you can differentiate with respect to t. dx divided by dt, the derivative of sine inverse u, that is 1 upon root of 1 minus u square. The square of a e to the power t, it is nothing but e raised to 2. And the derivative of a e raised to t, that is equal to e raised to 2. This is number 1. Again, y is equal to root of 1 minus e raised to 2t. Again dy by dt, substitute u. The derivative of a root u, that is 1 upon 2 root u, right? Again, the derivative of a 1, that is equal to 0. Minus sign remain as it is. E raised to 2t, derivative e raised to 2t into 2. 2 to get cancelled. Here you have got minus e to the power 2t divided by 1 minus e to the power. This is same. Again, by applying the formula, that is dy divided by dx. Here dy by dx. It is equal to dy by dt divided by dx divided by again see. What is dy by dt? Minus e raised to 2t divided by root of 1 minus e raised to 2. Again, what is dx by dt? This comes in the numerator 1 minus e raised to 2t divided by e raised to 2. Isn't it? Now again, if you observe this get cancelled. Minus sign remain as it is. E raised to 2t divided by e raised to t. If you take in the numerator, then e raised to 2t minus t means here you have minus e to 1. This is your result. But what is the result here? What do you want? That is, you have to consider the left hand side. Sin x plus dy by dx is equal to 0. Here the result, that is dy by dx, you have got as a dy by dx, you have got as a minus e to 1. Right. Now see, here we want sin x, therefore since x is equal to sin inverse of t, therefore if you take the function like this, sin x is equal to e to the power t, isn't it? So this is and this here, right mark. Again LHS sin x plus dy by dx. Now you can substitute. What is the value of a sin x? E raised to t. And what is the value of a dy by dx? Minus e raised to t. Here you have got that is here. So this is about the 6th, isn't it? Now I will take the 7th one here. See, 7th one. Say x is equal to 2b2 divided by 1 plus t square, and y is equal to a 1 minus t square divided by 1 plus t square, right? Dx divided by dy, you have to prove as a minus b square y divided by a square. Now see, again there are the 3 methods. You can do directly with respect to t, or you can substitute, right? If you observe this, see the function 2t divided by 1 plus t square. You can substitute t is equal to tan theta. So 2 tan theta divided by 1 plus tan square theta, that is the formula of a sin 2 theta. Here also 1 minus tan square theta divided by 1 plus tan square theta, this is the formula of a cos 2 theta. Means x is the function of a theta, y is the function of a theta. You can differentiate with respect to theta. The third method, see the third method. I will take the third method, that is x is equal to 2b t divided by 1 plus t square. Now I bring here x by b is equal to 2t divided by 1 plus t square, and y by a is equal to 1 minus t square divided by 1 plus t square, isn't it? No, this is first and this is second. Again squaring, I am going to try. I am trying here by to eliminate this t, right? For that purpose we have to consider the function like this, squaring and adding first and second, isn't it? Here you have got x divided by b whole square plus y by a whole square. It is equal to 2t divided by 1 plus t square whole square and 1 minus t square divided by 1 plus t square whole square. Right? Now again x square divided by b square plus y square divided by a square. Right? Now here you have got that 4t square. See, if you observe this, the denominator is same. 1 plus t square, 1 plus t square whole square, 1 plus t square whole square. The denominator is same, directly add the numerator. Therefore 4t square. Here you can make the expansion. 1 minus t square whole square. A minus b whole square means a square. Minus twice ab plus b square means here you have got 1. Again twice the multiplication of a two term and the square of a second term. Divided by here 1 plus t square whole square, right? Now x square divided by a square plus y square divided by b square. Here t raised to power 4 remain as it is. 4t square minus 2t square. Here you have got 2t square plus 1 divided by t square plus 1 whole square. Again, if you observe the numerator it is the perfect square of, that is this numerator, t raised to 4 plus 2t square plus 1. This is the perfect square of t square plus 1 whole square. Here also t square plus 1 whole square. And this is nothing but 1. This get cancelled. My x square divided by a square plus y square divided by b square. Here you have got 1. Now you can easily differentiate. See here, 1 upon a square remain as it is. The derivative of x square, that is 2x. 1 upon b square remain as it is. The derivative of y square, that is 2y into dy by dx, and the derivative of 1, that is equal to 0. Therefore, 2y divided by b square into dy by dx, it is equal to minus 2x divided by a square. Again, 2 get cancelled. Here you have got, that is dy by dx. It is equal to minus xb square divided by a square, isn't it? But what is your aim? Dx divided by dy. Therefore, dx divided by dy you can write as minus a square y divided by xb square, isn't it? So, what we have taken here? That is dy by dx. See here, this is the dy by dx. What is the proof? Minus b square y divided by a square x. Here b square. 1 minute. Minus x into b square divided by a square y. So 1 upon a square remain as it is. X square 2x. Y square. This remain as it is. This minus transfer minus 2 to get cancelled. Here you have xb square, right? And dx divided by dy, that is minus a square y divided by xb square. I have given that is wrong. That is minus a square y divided by xb square. This is the result. Again say, I will take this one. Again, see the problem. Again, x by b is equal to 2t divided by 1 plus t square. Y by a is equal to 1 minus t square divided by 1 plus t square. Squaring and adding x divided by b whole square plus y divided by a whole square. It is equal to 2t divided by 1 plus t square whole square. 1 minus t square divided by 1 plus t square whole square. Again, x square divided by b square. This is same. Here again, the square of this term, that is, this is 4t square, and a minus b whole square means 1 minus 2t square plus t to the power 4. This get cancelled. So what is the derivative? 1 upon a square remain as it is. The derivative of x square, that is 2x. 1 upon b square remain as it is. The derivative of a y square, that is 2y dy by dx. Now transfer this here, that side. 2y divided by b square into dy by dx, it is equal to minus 2x divided by a square. Again 2 to get cancelled. Here you have got minus x into b square divided by a square y, right? Therefore, dx divided by dy, it is equal to minus a square y divided by b square. So this is the result. Here also you can do, see, the result minus a square y divided by. Here the second method, see here. You can substitute t is equal to tan theta. See this method. Therefore, x is equal to b remain as it is 2 tan theta divided by 1 plus tan square. And again, if you observe this, this is the formula of a sine theta. Since x is the function of a theta, you can differentiate with respect to theta. dx divided by d theta. B remain as it is. The derivative of a sine theta, that is equal to cos 2 theta. And again 2 theta derivative. Right? This is. See. Again y is equal to a 1 minus tan square theta divided by 1 plus tan square theta. Again this is the formula of, this is a cos 2 theta. This is the, again dy divided by d theta. A remain as it is. The derivative of a cos theta minus sin 2 theta. Right? And the derivative of 2 theta, that is equal. This is 2, isn't it? Now again if you observe this, see. What do you want? We want dx divided by dt. See, dx divided by dt. Therefore, dx divided by d theta divided by dy divided by d. Now again, what is dx by d theta? Dx by d theta, it is nothing but 2b cos 2 theta. Right? And again, dy by d theta minus 2a sin 2 theta. But your result, it is totally in the form of x and y. Therefore, you have to substitute 2 to get cancelled, minus b by a. Again, what is the value of a cos 2 theta? See, what is the value of a cos 2 theta from third? From third, the cos 2 theta you can write as a y by a. Right? And what is the value of a sin 2 theta? X by b. Right? This is from first and third. From first and third. Again, minus b by a. Y by a. This b, again, this is y by a, x by b. This is x, isn't it? Y by a divided by x by b means what is y by a into b by x. Right? Again here you have got minus b square y divided by a square x. So this is the result. Minus b square y divided by a square x. This is the correct result, isn't it? I have given little, I think, wrong answer. So this is the correct answer, that is minus b square y divided by a square x. Right? In the first method also you have got the same answer. Right? So this is about the 7th one. Now I am going to take the 8th one here. See, the 8th. Again very important. Now x square plus y square is equal to t plus 1 by t, and x to the power 4 plus y to the power 4 is equal to t square plus 1 upon t square. And you have to show that x cube by dy by dx, it is equal to minus 1. Again this is very important. See. Now again, if you observe this, first you have to establish the relation between the two terms here, isn't it? Because you can't separately find out, because this is x, y and t. There are the 3 variables. Here also there are the 3 variables. Therefore you can't differentiate directly these two functions. Therefore whatever the terms they have given, whatever the functions they have given, first you have to establish the relationship between them. Therefore x square plus y square is equal to t plus 1 by t. And in the second term, they have given x to the power 4 plus y to the power 4. Therefore here, obviously, you have to make squaring both sides. Squaring both sides. Right? Here you have got x to the power 4. The second term, twice x square y square. And the third term, y raised to power 4. Again t square. Twice the multiplication, twice t into 1 by t. To t get cancelled, you have got 2. And here again you have got 1 plus t square, isn't it? Now you know x raised to power 4 plus y to the power 4. In two term, in place of this two term, you can substitute t square plus 1 by t square, right? Plus 2x square y square is equal to t square plus 2 plus 1 by t square. Again 1 by t square get cancelled. This get cancelled. Here you have got 2x square y square is equal to 2, isn't it? Now if you observe this, 2 to get cancelled, x square y square, it is equal to 2. Now if you do directly, here you have got the answer, that is dy by dx, it is equal to minus y by x. But here you want this result. See here, suppose you directly do this, this is what. Differentiate with respect to x. Differentiate with respect to x. See, x square remain as it is. ddx of y square plus y square remain as it is. d dx of x square, and here the derivative of a1 that is always equal to 0, right? Constant. X square remain as it is. Derivative with respect to x and your function it is of a y, 2 by dy by dx. Here again y square, and the derivative of a x square to x, isn't it? Therefore, x square 2y dy by dx, it is equal to minus 2xy square. 2 get cancelled. Here you have got dy by dx, it is equal to minus xy square divided by x square. Again 1y get cancelled, 1x get cancelled. Here you have got the result, that is minus y by x. But what do you want to prove? X cube into y dy by dx, it is equal to minus 1. Therefore, see here, this is one result, isn't it? They have not given this result here, but this result we have to manage, that is x square y square, it is equal to 1. To get x cube, you have to bring this x square in the denominator of what here 1. Therefore, y square is equal to 1 upon x square. When you write like this, then and only then you have got this answer here. Now differentiate with respect to x. See, the derivative of a y square, that is 2y dy by dx. Here the derivative of a 1 upon x square, that is minus 2 divided by x cube, isn't it? Again 2 get cancelled. This x cube you can multiply here, x cube into y dy by dx, it is here you have got as minus 1. So what is the result they have given? The answer is minus y by x also, and the answer is here, that is x cube y dy by dx, it is equal to minus 1. In this way you have to manage the problem, isn't it? Now again I will take one more problem, that is 9th. This is also very, very important here. Here see, the another type, that is type number 2. Whatever we have studied, that is the type number 1, type number 2. Now the question is like this, differentiate 7 raised to x with respect to x raised to 7. If the question is like this is also the parametric term, but the type is second type, isn't it? Differentiate 7 raised to x with respect to x raised to 7. Can you do right this? Differentiate x raised to 7 with respect to d of x raised to 7. 7 raised to x raised to 7 like this. For that purpose, what you have to do? First you have to substitute u is equal to 7 raised to x and v is equal to x raised to 7. Now see the question, differentiate. This is nothing but u with respect to v. Means what do you want to differentiate here? What do you want to find out? Differentiate u with respect to v means you have to find out du divided by d. Therefore, in the second time, you have to substitute u is equal to 7 raised to x and v is equal to x to the power 7. Now, it's very simple. U is the function of x. You can differentiate with respect to x. Du divided by dx, that is 7 raised to x log 7. Right? And again, this is 1. V is equal to x to the power 7. It's very simple. dv divided by dx, that is 7x to the power 6. This is 7. Isn't it? Now, we want to find out dy by dx. Sorry, du divided by dy. Therefore, this you can write as a du divided by dx. Here, dv divided by dx. What is du by dx? That is 7 raised to x log 7. And here again, 7x to the power 7. Now here, what is the power here? That is equal to 1. We can write 7 to the power x minus 1 also, or write down as it is, that is du divided by dy. This is the second type of example. Now again, suppose I take one more problem here. Differentiate sine inverse 2x divided by 1 plus x square with respect to cos inverse 1 minus x square divided by 1 plus x square. Right? Now let us take this. Again what you have to do, let u is equal to sine inverse of 2x divided by 1 plus x square, and v is equal to cos inverse 1 minus x square divided by 1 plus x square. Now differentiate u with respect to v. V means to find du divided by. Now let us take u is equal to sine inverse 2x divided by 1 plus x square. Now you can make the substitution, isn't it? Because this is again the inverse trigonometric function. Put x is equal to tan theta. If you substitute sine inverse, this is 2 tan theta divided by 1 plus tan square theta. Again this is the formula of what? Sine 2 theta. This is the formula of a sine 2 theta. Sine inverse sine get cancelled. U is equal to 2 theta. Since in both the function, that is u and v, you can make the same substitution, that is tan theta. Therefore here you can differentiate with respect to theta. But if the substitution in u and v are different, then that u, that theta, you have to convert in the form of x. But since you substituting tan theta in the v also, you substituting tan theta in the u also, therefore you can differentiate with respect to theta. Therefore du divided by d theta you have got as a 2. This is number 1. Again v is equal to cos inverse. Same substitution, 1 minus tan square theta divided by 1 plus tan square theta. Then here you have got, that is cos inverse. This is the formula of a cos 2 theta. Again v is equal to cos inverse, cos get cancelled. Now differentiate with respect to theta. Therefore this is 2. But what do you want to find out? Du divided by dv. Therefore du divided by d theta, dv divided by d theta. Again du by d theta, that is equal to 2, and dv by d theta, that is equal to 2. Answer. But if the different substitution, then that theta you have to convert as a tan inverse of x. There also you have to convert, isn't it? But since the same substitution, you can differentiate with respect to theta. Now the last one here, parametric. Differentiate 3 raised to x with respect to log 3 to the base x. Now again see, very simple. You have to let u is equal to 3 raised to x, v is equal to log 3 to the base x, to find du divided by d, isn't it? Again u is equal to 3 raised to x. What is the derivative of a raised to x? A raised to x log a. Therefore what is the derivative of 3 raised to x? Du divided by dx. It is equal to 3 raised to x log 3. Right? Again this is number 1. V is equal to log 3 to the base x. You know the derivative, that is log of x to the base a, 1 upon x log a. But they have given the base as a function and the function as a constant, isn't it? Therefore what you have to do, v is equal to, you have to write as a log 3 divided by log x. Right? Again you can use the division rule also, or you can do directly, because see here dv divided by dx, log 3 the constant term remain as it is, and 1 upon log x, the power, that is nothing but 1. Again you have to apply the formula, 1 upon x to the power n. What is the derivative of x to the power n here? Minus n divided by x to the power n plus 1. Here also this you have to consider as a u, means minus 1 divided by log x whole square, and the derivative of log x, that is equal to 2 by x. Therefore here you have got minus log 3 divided by log x whole square into what it is. This is simple. Therefore du divided by d, it is equal to du divided by dx and dv divided by dx. What is du by dx? 3 raised to x log 3. And here again see, minus log 3 divided by log x whole square into x. Isn't it? Therefore, a divided by b by c means a multiplied c by b. That is, therefore, this term comes in the numerator x, and here again minus 1. Therefore, log 3 get cancelled, minus 3 raised to x log x whole square into x. This is about the parametric function. So here I have finished, that is the parametric function, the derivative of a parametric function, and the next session I am going to take the second order derivative, and the last year, that is the nth order derivative. When we finish the nth order derivative, there the derivative get completed, because there are the so many functions are there. We have studied, that is the first chain rule, then we have studied the inverse trigonometric function, then we have studied the logarithmic differentiation, then we have studied the derivative of an implicit function. Now today we have studied the derivative of a parametric function. So every function, it is very lengthy and the variety of a problem. So here I have finished the derivative of a parametric function. So the student, if you like my video, then share it and subscribe my channel. Good day for you.